Okay, question 16. Right, so a bit of algebraic proof. There is one thing I'm just going to quickly talk to you about very briefly so that you are coming at this with the right kind of knowledge. If you have a bracket with a minus sign at the front, so let's say we had, I don't know, x plus 3 and a minus sign at the front. If you wanted to expand that bracket, it means you're timesing everything by minus 1. It's called distributing the minus sign. Alright, so if you wanted to write this without a bracket, you would actually have minus x and minus 3. Because you'd have to times everything in the bracket by minus 1. So x times minus 1 is minus x. 3 times minus 1 is minus 3. Basically, all the signs would swap. So positive becomes negative, positive 3 becomes negative. Okay? With that in mind, let's have a look at this question. So, n is an integer greater than 1. Prove algebraically that n squared minus 2 minus a whole bracket squared, n minus 2, is always an even number. Alright, so even numbers are generally, an even number is kind of like you can factor out a 2. So, 2 times table. 2 times anything is going to be even. So it might end up going this way with factoring out 2 at the end. So we'll have a look. Right then, first things first, we kind of need to sort this bracket out because you've got n minus 2 all squared. So let's just do that. It's the first thing I'll have a go at. So n minus 2 all squared, you should know, is basically when you square something, you times it by itself. So that went. So you've got n minus 2 times n minus 2. Alright, so we're kind of expanding these two brackets. Foiling it out, or whatever method, crab claw, loads of names for expanding two brackets. N times n is n squared. Minus 2 times n is minus 2n. And then you've got the other n times minus 2, another minus 2n. And then minus 2 times minus 2 is a positive 4. So that's that bit there. So I'm going to rewrite this whole thing out again with my expansion in place of this. So this is quite a tricky question because the minus sign, this minus sign here, is going to cause a lot of people to make mistakes, I think. So you have to be careful. N squared minus 2 minus, put a bracket in, all of this bit here, because that's what happened when we expanded this. Okay, we've got n squared minus, I should have simplified this really, shouldn't I? Minus 2n is minus 4n plus 4. That's the expression that we're kind of dealing with. Okay, so you can see why I spoke to you about this distributing the minus sign up here, because we've got a situation where we have to do it now. So everything in the bracket is going to swap its sign. So when you write it out, when you distribute the minus sign through the bracket, you end up with n squared minus 2. Here we go, let's distribute it. So that's a positive n squared, so that becomes minus n squared. That's a minus 4n, so that becomes a positive 4n. That's a plus 4, so that becomes a minus 4 on the end. Okay? Hopefully there's some things that will cancel out. So you've got n squared here and a minus n squared there, so they're going to go. And you've got 4n, no other n's, so we've got 4n, minus 2 minus 4, that's minus 6. So that's our kind of final expression. And we need to show that this is always an even number. And I said to you, well, if you can factor out 2, that will prove that it's always even, because whatever you've got in the bracket will have to be times by 2 at some point, and that makes it even. Anything in the 2 times table is even. We can factor out 2 here. So factor out the 2, and you'll be left with 2n minus 3, and there we go. So that kind of, therefore, this is going to be a multiple of 2, which, is therefore an even number. Therefore, even. Okay? So hopefully that's given you an idea of how to do that and avoid this pitfall here with this minus sign set outside of a bracket That's how you're going to deal with that. Expand it and then keep it in the bracket and then distribute that minus sign through the bracket, swapping the signs to make sure you get everything correct.